We have a lot to cover in a short period of time, so let's In math, science, and engineering, we see lots of equations. Equations are statements of equality between two expressions consisting of variables and/or numbers. For calculus, it's important we understand a specific type of equation called functions. Functions are any equation that have one possible range value for every domain value. So graphically, there are never two or more points for one x value. Let's look at some examples. For this one, it's easy to see that every x value will only result in one y value. For this equation, let's look at it graphically. It does have 2 points for y values, but every x value still results in only one possible y value. This is in fact another function. This, on the other hand, is not a function. We see 2 different values for y for one value of x, so therefore it's not considered a function. If we look at the previous function and only consider half of the y equals x squared, so only take the positive side, now this is a function. And yes, if you plug in negative numbers, it will give you imaginary numbers, but that doesn't change the fact that it's still a function. The last classification we have to consider is one-to-one functions. This just means that every x value gives you a unique y value. So revisiting the ones we looked at, this is a one-to-one function. While this one is still a function, it's not a one-to-one function. At this point, we've been talking about functions in the form of y instead of f of x, but we need to get used to seeing function of x, f of x. And now keep in mind, this is the same thing, so don't let the getting fancy confuse you. And this format can be useful, so try to see the positives and how it can help you. In addition to this format, we need to get used to plugging in more than just numbers. In simplifying this, it brings us to a reminder of F.O.I.L, which we use to simplify x minus 2 squared. So based on the first, outer, inner, last, we have a new expression that we can plug back into our original equation and continue our simplification. So this would be the function of x minus 2, so plugging in x minus 2 instead of just a number. Finding the roots of the function means finding where the function is equal to 0. We start by factoring out the function we're working with. Then we determine the value or values for x when the function is equal to 0. You can verify that you found the root of the function by plugging it back in, looking online, or using different software. Function composition entails plugging the second function into the first function. Keep in mind, order matters. First, we plug in the function g of x for the x variable in f of x. To factor this out, we will revisit F.O.I.L again and continue from here. We will further factor this out. Once we have our function in polynomial form, we can use least common multiples to help us see if we can factor this out further. In this case, it doesn't factor, so we have our answer. And again, order matters. So this is an example of plugging g into f, the opposite direction. Sometimes f of g of x will equal g of f of x, but never assume this. If the function compositions are equal to each other and x, then you have an inverse function. The inverse function will return the x value originally plugged into the first function by using the y value, or the result. You can also find inverse functions using this approach. And just when you think you've got it, you may see something like this, but don't let it fool you. It's the same thing with just one function instead of 2. When thinking about trigonometric functions, don't forget about SOHCAHTOA. This can help you remember sine, cosine, tangent. It's helpful to graphically visualize them. Here we can also see that sine and cosine will never result in values greater than 1 or less than -1. When thinking about trig functions, we need to also remember the inverse trig functions, cosecant, secant, cotangent. It's helpful to graphically visualize the inverse trig functions as well. Keep in mind, you will use radians a lot in calculus, so it is important that you begin or continue to get more comfortable with them. Also, a reminder, you rotate counterclockwise for positive angles like shown, and clockwise for negative angles. Let's revisit this graph by looking at a circle with a radius of 1. This can help us remember the relationships of sides for right triangles. This point on the graph shows us the sides for a 30, 60, 90 triangle, and this point for a 45, 45, 90 triangle. And just like before, you can also multiply by 2 to see the numbers that you may be more familiar with. But really, just get used to radians because they will be everywhere. And when using a calculator, Google, or software, make sure you pay attention to degrees versus radians. Pythagorean theorem can be useful to help you calculate a common trig identity. Sine squared of theta plus cosine squared of theta equals 1. There are also many other trig formulas that you need for solving trig problems, and I recommend reviewing them. This is one example of solving a trig equation. Once we find these two values for cosine of x, we can refer back to our circle graph to figure out what x equals. For 1/2, we have 2 possible angles. Once we determine our angles within one rotation of each value, we can define the answers as these values plus any additional number of rotations. Our solutions will look like this, with plus 2 pi times n to change the angle by any full rotation. Exponential functions model a relationship in which a constant change in the independent variable gives a proportional change in the dependent variable. As always, exploring graphs can help. One common example where an exponential function is used is to calculate population growth. Keep Keep in mind, your graph may not look exponential if you are looking at too small of a range of x values. Logarithms are written as shown. Logs and log tables are used for various applications such as calculating entropy and understanding musical tone intervals. Two common logs are natural log and normal log. The logarithmic function is the inverse of the exponential function. Hopefully you're feeling more prepared for Calc 1. Be sure to subscribe and you can follow me in this Calc 1 series as I incorporate MATLAB throughout.